Good morning. It is a pleasure to be here. I want to begin by thanking the entire Forward 2023 team for their amazing, for all the incredible work that they've done and for the warm way that they've welcomed us here to Puerto Rico. So it's been a great experience. I'm running the Office of Space Commerce in the U.S. Department of Commerce. Obviously, there's so much going on in space now. There's a tremendously exciting exploration program that NASA is executing, the Artemis program, to go back to the moon with the rest of our international community. There's an amazing scientific journey that's going on at NASA and space agencies around the world. And what I'd like to focus on today is the third exciting element, which is the incredibly robust commercial activity which is going on in space today. You know, there are a lot of, although I'm back in the government now, I've also worked in industry, in the satellite communications industry, in the launch industry, so I've sort of seen this from both sides. And it's a tremendously exciting market that is growing at a phenomenal rate. Now, I'm using some numbers here. You can see over $200 billion. This was in 2021, so the numbers are larger now. These are actually pretty conservative numbers. These numbers come from the U.S. government's Bureau of Economic Analysis. There are other numbers that you will see that are much larger. Typically, that's because space is an enabling technology for so many things. So when you say, what is the value of a GPS signal? I mean, how can you translate the many, many, many implications, the savings of fuel on aircraft, the agricultural revolution that can happen, the self-driving cars? So you pick one space technology and its impact, you can look at the numbers, but the impact is felt throughout society. There has been a tremendous growth. If you look at the numbers over the years in the number of people in the space industry, a lot of new dynamic companies starting. Private investment has been growing year over year in the space industry. Of course, new technologies providing a different view of the world. There was a lot of interesting satellite programs being developed that will image the planet in different wavelengths, providing different information for use in either land planning or agriculture, or and we've seen when wars happen, how do we see what's going on in the world? Today, we see that because commercial companies have imaging satellites around the world. So the first images that you tend to see in the newspaper that inform you of what's going on have been provided by a commercial entity. So it is truly a revolution. This revolution that's happening also comes with complications, of course, because we have more people using space, more space debris. Things don't just fall out of space. Those things in space are traveling at 18,000 miles an hour. So any intersection, unplanned intersection of space objects can have a catastrophic event. So let me talk a little bit about my office. First of all, I like to say we were for commercial space before commercial space was cool. So this office was started, if you can believe it, in the Reagan administration, late 1980s, back when the idea of commercial space, many people thought would be laughable, because they thought only governments can do space. There's no role for the private sector here, maybe as a contractor to the government, but not to own companies. Well, obviously, we live in a dramatically different world today. So one of our big jobs is advocacy. We work within the government to encourage use of commercial technologies. We work within the government to try to prevent competition with the U.S. commercial sector from the government. We work internationally to try to open markets and to build relationships. We've done a lot of international work this year to try to build bridges between the different commercial sectors around the world. So that's an exciting part of our job. We also had a big new responsibility come our way a couple years ago. So under Space Policy Directive 3, the President said that the responsibility for tracking objects in space for commercial and civil, so for scientific and commercial activities, would move from the Defense Department to our office within the Department of Commerce. And so this has been a major undertaking. Currently, Sandy Magnus, ex-astronaut and extraordinary engineer, is leading our effort, and we are, our job will be to, by the end of this year, to stand up an initial capability that will provide warnings for commercial satellites of potential collisions in space. And again, because of the growth in the amount of debris in space and more actors in space. For example, initially, satellites could be counted in the single digits, but now we have fleets of satellites. The Starlink fleet alone is over 4,000 satellites, and we have additional large constellations planned by China, by Europe. And so how we manage this increasing growth, how we manage the space traffic, if you will, becomes a critical issue. And our office is working with the commercial sectors, working with the Department of Defense to try to bring the best technologies forward to do this. It'll require new sensors, it'll require a lot of new analytics, and it'll require international coordination. I like to tell people, if you want to understand what the future space traffic is going to look like, just think of the international banking industry, right? Millions of transactions a second, global. You can use your credit card in Tokyo or you can use it in Istanbul. So we have to have a way that the planet talks to itself about what's going on in space. And it's got to cross cultural boundaries. We have to engage both our friends and the people who may not be our friends. Because as long as these people are in space, if we don't have good communication, we will not be able to fly safely. So a huge responsibility which has come to our office, and we, again, welcome participation of the commercial sector in helping to solve this problem. We are also a regulator. We regulate, for the United States, we regulate anything that images the Earth. We're the regulator for that. So we have a team that does regulation of imaging satellites. Just a quick note, if in the United States, there's no single regulatory entity for space, commercial space activities. The responsibility is actually spread across the government. So a while back, 1967, the nations of the world got together and they drafted what's called the Outer Space Treaty. And the Outer Space Treaty said many things, but one of the things it said is that nations are responsible for the activities of their commercial sectors. So if, for example, if Elon Musk accidentally crashes into a Chinese space station with his Starlink satellites, ultimately, it's the United States government which is responsible to China. So as a result, the US government agreed in that agreement, the 1967 Outer Space Treaty, that they would authorize and supervise the activities of the commercial sector. So we've taken that to mean that you have to have a license before you can go do activities in space. So who does the licensing? Well, Department of Transportation through the Federal Aviation Administration does licensing for launch and recovery, but today they don't have any authority in space. Spectrum management, you can't go to space without spectrum to communicate. Two independent bodies, the Federal Communication Commission does spectrum management for the commercial sector, the National Telecommunications and Information Administration does it for the government. Sensors from space, that's us, the Department of Commerce, and export control. Again, two flavors. Department of State does ITAR, or National Security Concerned Issues, and the Department of Commerce does the rest of commercial. So obviously, today, we are imagining activities that were not imagined before. So as we look forward to the near future, we see commercial space stations, we see refueling operations in orbit, we see repair operations in orbit, we see commercial sector potentially landing on the moon, potentially wanting to mine lunar or asteroid resources. All of these things are today unregulated, but still the responsibility of the US government. So as we look forward, we are asking who is going to do these activities. So it's a very dynamic environment. Politically right now, the House has a bill that they like that would provide a direction on how to regulate. The White House a couple weeks ago released a draft that would grant to the Department of Commerce a significant expansion of our authority for regulating the future of space. So we're really excited. The Senate has not spoken yet, and presumably they will be doing so over the next weeks and months. So it's an exciting time, and it goes to show you how fluid the environment is that we are currently in, and how much opportunity there is to actually have a meaningful impact on huge decisions that will be made today about how we manage the future. Anyway, I'd like to, if I had a few minutes left, maybe offer to answer a couple of questions, if there are questions. But I'd just like to say that we at the Office of Space Commerce welcome the partnership with Puerto Rico. We welcome the linking all the commercial companies of the states of the United States with the great activities that are happening internationally. We have the tools and resources of our office and also the International Trade Administration, which works globally. So we will look forward to working with you. We look forward to working with your companies to making this an exciting future. I'm happy to answer any questions. I think I have a couple minutes left if there are any.
I'm going to grab the mic and go to the audience, just in case there's a question. I actually have a question. Can I ask a question?
Sure.
Sputnik was launched in '57, right?
Yes.
And there have been many launches of satellites. Is there such thing as satellite pollution?
Yes. That's what we call space debris. What happens is the satellites, depending where they are, degrade over time, eventually return and mostly burn up, although sometimes they don't completely burn up, which is another problem. They will do so over time, but when something is in very low Earth orbit, lower than say a couple 200 to 400 kilometers, it will usually within a decade, depending on a lot of things like solar wind, that will naturally come out of the sky. But if you're in geostationary orbit, which is at 20,000-ish miles, then the natural degradation of that orbit is probably on the order of 50,000 years. So we do a lot of the stuff that we put up before we used to do things that we didn't know were bad, like we'd leave fuel in upper stages. Eventually, some of that fuel exploded, creating shrapnel. All that shrapnel is also traveling at 18,000 miles an hour. So then we did some really dumb things globally. The US, China, India, Russia all have had at one point anti-satellite programs, actually national security programs to destroy satellites in space. Recently, the Vice President Harris has been an advocate for a global ban on ASAT testing in space because it's a terrible idea. Because the debris doesn't just fall down or go away. It's not like sinking a ship and it falls to the bottom of the ocean. All that debris just is a big, huge cloud, which is still all of it lethal. So we have a ton of issues, and we are working with our colleagues in the Defense Department and State Department to try to raise awareness and to try to put in place, working with the United Nations, try to put in place rules to regulate how much pollution we put in space in the future.
We do have a question here.
Hello, thank you for your presentation. Ricardo Wigos from the Science Trust. Two quick questions. One, I heard that your office doesn't have any activities in Puerto Rico at the moment. And what would be low-hanging fruits that you see could happen in terms of your office being more engaged in Puerto Rico? And the second quick question is, I'm sure you heard about the spaceport, and I saw in your presentation that that's not your jurisdiction, but any thoughts on the spaceport on Puerto Rico?
Okay, several things. First of all, our office does not have any direct activities in Puerto Rico, but we do work, I mean, our office is mostly in Washington, D.C., and we do gather, we mostly focus on working with companies to help them reduce barriers, to get access to contracting, to get access to global markets. So we would be happy to work with you on any of those things. Going beyond our office, of course, our office is in NOAA, and I know that NOAA is working directly with many projects on climate change and fisheries and a bunch of activities here on the island. And then thirdly, my boss, Deputy Secretary Don Graves, has a passionate interest in Puerto Rico, and as I understand it, has been a frequent visitor and has another trip coming up very shortly. So I think the department is deeply engaged, and my office would like to be more engaged with you. If we can, let's find something to work on. The spaceport is the responsibility of the FAA. I know that you're in dialogue with them. I'm actually, I think, getting a briefing today on where that dialogue is. It's an exciting concept. I mean, as space vehicles proliferate, particularly vehicles that can land and are reusable, then I think the demand for more spaceports globally will grow. And I think Puerto Rico is well positioned in that future growth.
I'd like to bring back the issue of space pollution because there was a recent NOAA study that flew some high altitude instruments and found that as these satellites are decommissioned and they fall off, they're leaving heavy metals and trace gases in the stratosphere. This is a paper published in PNAS, National Academy of Sciences. So there may be a situation in the foreseeable future where the Office of Security Commission may have to regulate the environmental impacts that debris may have on the health of our atmosphere. And that is still very preliminary, but I was trying to see what your thoughts were on the likely impacts a lot of this growth may ultimately have on the sustainable use of space.
Okay, that's actually excellent and timely question. We actually just met with the scientists that are doing that work, and the question is, as objects re-enter, they tend to mostly burn up or turn into, obviously all the components of the satellites are then atomized into the atmosphere. So the question is, one of the questions they're looking at is they found trace metals that they thought shouldn't be there. Now obviously a lot of things enter through the atmosphere. You have meteorites that are coming through all the time with iron and other metals, but what they found are traces that they hadn't detected in other. So the question, the questions are, we're at the very beginning of that science, but the questions are obviously, one, do we understand the phenomena? What is the impact of those exotic materials being there? Why is this relevant? Well, as I said, these mega constellations are being planned. All of those mega constellations assume that the thousands of satellites that are going to be launched are going to be deorbited and mostly burn up in the atmosphere. Today, there's not sufficient scientific base to understand what is the impact of that. Just like when they started launching mega constellations, nobody thought through that the solar panels on those satellites were going to, they were going to be a big problem for terrestrial astronomy and for telescopes. So, like all technologies, we kind of move forward in kind of a lurching pattern, right? We take a step and then sometimes we don't realize what those certainly with artificial intelligence, the whole future of AI is sort of mysterious right now. And so we invent these technologies, and then we have to understand them. The good news is that our team is on it today. They're doing the science. And if there's a problem, we'll be able to fix it. Maybe by, just as they've looking for many, many different ways, changing the reflectivity of the satellites to try to protect terrestrial astronomy, we will have to respond. But it's a serious, I'm getting flashed now telling me that my time is done, but it's a serious problem, and we are looking at it, but let's let the science lead on this, and if there's a problem, then we'll have to address it by changing materials that we use. Thank you so much. I'm looking forward to an exciting day, and